Alright, so 4.5 exponential and log equations. The first type of problems, it's the one video that I provided. I put it on the Google Classroom yesterday. It's like only one type of a whole bunch of different problems in the assignment, so it wasn't all that helpful. But it has an exponential equation looks like this. And we're asked to solve it. One technique we can do when we have an exponential equation like this is you could look to see if you could rewrite both of them with the same base. So I have 2 as a base on the left and 8 as a base on the right side. It would be hard for us to write 2 with a base of 8, but we could write 8 with a base of 2. What is 2 to what power is 8? 3. So we could say this is 2 to the 3x plus 1. This is 2 cubed to the 2x. And then we can multiply, like if I have x squared to the 4th, we know that that is x to the 8th. So we multiply these exponents. We have 2 to the 3x plus 1 equals 2 to the 6x. And then you can either kind of by inspection, seeing that the bases are the same, the exponents must also be the same. Or if we wanted to, we could do a log base 2 of each side, which just gets rid of the bases. So basically it's 3x plus 1 equals 6x. So x equals 1/3. Okay, so this type of problem, we can write them with the same base, and then you just set the exponents equal to each other. We can't always do that, but that's one possibility. Here, I'll have you try one. That's a 4x. See if you can get anywhere. This is harder than the one I just did. See if you can get anywhere with it. So the first thing you're trying to do is find out what base each can be written with. Anybody know what base we should use here? 9 would work. I don't think it's the easiest. I would choose 3. So you could write 9 as 3 squared. What about 1/3? That's 3 to what power? -1. Very good. Okay, once I get here, we do have to multiply the exponents. So it's 3 to the 2x plus 2 equals 3 to the -4x. So then you can say 2x plus 2 equals -4x. So x is -1/3. So far so good? Okay, so that's fine and dandy as long as you can write them both with the same base. What if I have an exponential equation that has like 8 equals 3 to the x? Make it really nice and simple. So if I have 8 equals 3 to the x, I can't believe it. That's the same problem in your notes. I just looked at that. That's how creative I am. Oh, all right. 18 equals 8 to the x. Okay, so we need to undo, we're trying to get x by itself, so we have to undo the 8 to the power. How do I do that? Log base 8. Very good. So log base 8, that one kind of looks like a snowman. Log base 8, so we have the log of 18 base 8 equals x, so that's our answer. So that's just a number. I think the easiest to figure it out on your calculator for looking for a decimal answer is just to write it as log of 18 divided by log of 8. Use our change of base formula. You could type in log 18 divided by log 8, and that'll spit out the answer. Some of you have discovered that if you go to math and go down to letter A, you can type in any base you want for your logs if you have a TI-84. So just go to math down to letter A, and then you just have a log base option there. So log of 18 divided by log of 8. So 1.34. So notice if I did natural log of 18 divided by the natural log of 8, you get the same answer. So it doesn't matter what log base you choose, as long as the ratio, they'll always be the same. Or you could have gone to math, all the way down to A, so I can do log base 8 of 18 and get our same answer. Alright, so that one has just, it's a number equal to an exponential. Sometimes you have an exponential equal to an exponential, and you can't write the bases the same. I'll just say to the 2x. Okay, so I can't write 3 with a base of 5 very easily. You can't write 5 with a base of 3 very easily. But we have to undo them, so we're going to do a log, and it doesn't matter what log we use. We can use the log log, we could do log base 12 if we wanted to, or natural log. I prefer natural log just because I can write in cursive, and it's only 2 letters. Do you even know cursive? Did you learn? Is this the generation without cursive? You still learned it? I wonder if they're still teaching.
Like, I think they're just now like stopping.
They're stopping it?
Yeah, like it's slowed down. Like we didn't learn when I was in like elementary school. We didn't learn it a lot. We still have, but we still had sheets we had to fill out.
Okay.
But I don't think they're really learning it much anymore.
Yeah, our teacher tried to make us learn in 2nd grade, but we just didn't care. We basically went on strike for the entire time.
You struck as second graders?
And it worked.
How?
We stopped doing it.
Whatever works. Okay, so I chose natural log. Again, I could have done log, but then one of our properties of logs is we can take our exponent. Remember what I could do with the x plus 4? Put it out front. Yep, I can take this and put it out front. So I have x plus 4 times the natural log of 3. Same is true with the 2x, so it's 2x times the natural log of 5. So now we have a linear equation. Even though it doesn't really look like a linear equation, it is. Natural log of 3 is just a number. Natural log of 5 is just a number. So I'm going to show you how to do it, leaving them in exact form, like natural log 3, rather than change it to a decimal. And then I'll show you the decimal version. So right here, I'm going to distribute. So I have natural log of 3 times x plus 4 natural log of 3. We need to get all of our x's on one side, so that means I have to move this guy over to this side. Alright, what do I have here? 2x. Well, how many x's do I have? I have 2 natural log of 5 minus natural log of 3 x's. It's like that coefficient minus that coefficient. And what's my last step? Divide. Yep. Divide by how many x's we have. I think that most students will find it, like there's my exact answer. That's what x is. Most students would probably, it would make more sense to you if you changed it to decimal, to the decimal route. Because this was probably a little confusing. Yes? A little bit? Okay. But if we change it to decimals, natural log of 3 is just a number. So what is it? It's 1.1. So I can do the same equation right here. I'm going to do x plus 4 equals natural log of 5 times 2 is 3.2 x. That's the same problem. I just changed my natural log of 3 to 1.1, and natural log of 5 times 2 is 3.2. So now I can distribute the 1.1 and subtract. That looks like it's 2 point something. 2.1. And that would be just fine. Okay, so if you have, back where we started, we had 3 to the power of something, 5 to the power of something. You can start by taking a log. I just chose natural log of each side.
Does it not matter, or do you want to use one or the other?
Does what not matter? Like,
Using that, like, because you said you could have used natural log or log.
yeah, it does not matter. No.
Okay.
All right, so let's try one like this. Alright, so I could do an LOG of each side if I wanted to switch it up. You probably all did natural log just because I did. Is that true? Alright, so I'll try not to confuse you. I'll just do natural log. Just to make the point that we could have done a LOG of each side. Okay, so bring the 3x out front. Bring the x minus 1 out front. Raise your hand if you left it in exact form, like the log form. Raise your hand if you did decimals. Alright, so more people did decimals. So I'll show you both ways. So move the x's over here, so subtract natural log of 6 x. So how many do I have? A 3 natural log of 2 minus natural log of 6. That's how many x's I have. And then divide by all that stuff. So that's our exact answer. Decimal wise, anybody have one? What's natural log of 2? Anybody have that? 0.69?
Yeah, we're just straight natural log.
Okay. So and then times 3 is 2.08, I'll say. X equals natural log of 6, 1.79. Alright, so then I can just subtract 1.79x. And then divide. Negative 6.17. All right, anybody get that? All right, a few people. Questions on that? questions so far? So that's basically, that's all we're going to do as far as exponential equations goes. There's one like this in your notes. I'm not going to talk about this today. I'll probably talk about it tomorrow. So it gets to the point where it's a pretty involved problem that we'll talk about tomorrow. It's used the quadratic formula, it's a quadratic type, and we just don't really have time or energy to work tomorrow. So that's all exponential equations. Now we're moving on to log equations, how to solve log equations. What's the inverse of a log? What's the opposite operation of a log? Log. So everything we've had so far has been exponential. You just have to do a log. Now if we have a log, say I have a log of 2x minus 3 equals 10, we can solve this knowing that exponentials are inverses of logarithms. Well, what's the base of natural log? No, it's e. There's an e right there. So to undo natural log, we'll do e to the power. So we'd have 2x minus 3 equals e to the 10, which is a huge number. I'm just going to leave it in terms of e, and I can just add 3 and divide by 2. So that's one where I probably would just leave it in exact form. It's not as messy as the other type. All right. Let's say I have, I'm going to use the same one as the notes. All right, so if we have two logs on the same side with the same base, the biggest mistake students make here is they want to do a 2 to the power right away. They want to do 2 to the power of this, 2 to the power of that, 2 to the power of that. So we end up with x squared minus x plus 4 equals 2. That's not correct. You can't do a 2 to the power if you have more than one term on one side. It's not going to undo it. So what we need to do is condense it. Okay, we've done that before in 4.4 where we have to condense two logs. Well, if you're subtracting, do you remember what you do with the stuff on the inside? You divide them. Very good. So we can rewrite this as the log of base 2 x squared divided by x plus 4. Since we're subtracting, we divide. We haven't done anything to the right side. Okay, now we can do what to each side? 2 to the power. Very good. See if you can finish this problem. All right, so it's in your notes, so a lot of you just kind of follow along if you got stumped. But we do 2 to the power of each side. So I get x squared over x plus 4 equals 2. We multiply by x plus 4. And we have a quadratic equation. And we need to have 0 on one side, so I have a positive x squared on the left, so I'm going to move everything else over. And now what? Factor, very good. So two numbers multiplied to be negative 8, add to be negative 2, or negative 4 and 2. So x minus 4, x plus 2. So we end up getting 4 and negative 2 for our answer. Now one thing to consider when we're doing these log equations, we've got 4 and negative 2. We might have done everything correctly, but one or both of these might not be correct answers. They might be extraneous solutions. So let's plug 4 back in, and you can't take the log of a negative number and you can't take the log of 0. It's got to be positive in the inside. If I put 4 in for x here, am I taking the log of a positive here and here? Does 4 work for both of them? Yes, it produces a positive inside here, positive here, so 4 is good. Negative 2 is our other possibility. It might be tempting to say that's not a solution because you can't take the log of a negative, but if you plug it in, that's the log of 4, And that's if you plug -2 in, you're still taking the log of a positive. So both of those are correct answers. All right, so if you have multiple logs on one side, you have to combine them. So the other next problem would be natural log. Again, it would be tempting to do e to the power right away to get rid of all the logs, but you can't do that because there's two terms on that side. So see if you can solve that equation. Try not to look at your notes, but if you have to, go ahead and look, see if you get stuck. All right, so if you have two logs on one side, and if you're adding, you're going to want x minus 2 times 2x plus 1. Now we can do e to the power of each side. So I get 4x plus 2 equals, I'll FOIL it out, 6x squared minus x minus 2. And once again, we need to get 0 on one side. I have positive 6x squared on the right here. So I'm going to move these over there. So 0 equals 6x squared minus 5x minus 4. And you could use the quadratic formula. You could complete the square if you want to bring that back. Easiest, I think, is probably to factor it. So multiply by -24 and add to be -5 or -8 and 3. So that -5 is going to be written as -8. -5x is -8x plus 3x. And then like a double box problem. 2x, 3x minus 4, and 1 times 3x minus 4. So it's 2x plus 1 times 3x minus 4 equals 0. So we get -1/2 and positive 4/3. Those are my two solutions. Let's see if they both fit in the domain. So -1/2, if I plug it in here, that gives you -2 plus 2 is 0. We cannot take the natural log as 0. If I plug -1/2 in here, you're going to get a negative. So you can't take a natural log of negative either. So -1/2 is not a possibility. 4/3, that's going to be positive. That's going to be positive, and that's going to be positive. 4/3 is the only solution for this problem. Questions on anything we talked about today?